All right, guys, I want to talk to you about seafloor spreading. Now, I know that we are studying plate tectonics and these kind of things, but I assume that you have an understanding, or at least a basic understanding, of how plate tectonics work in the Earth. And because it's an oceanography class, I really want to focus on the ocean at this point and how the plate tectonics are moved and how these things happen in the ocean, because it becomes a major piece of what we see and what our oceans look like. All right. First thing is when we get down to the very bottom of the ocean and we look at very deep hydrothermals, and these what this is very basically cracks in the earth where there's lots of geothermal activity occurring and lots of hot water being pushed and ventilated out of these deep ocean ridges. We find life here, and some of the life we find are something we call the ocean tubes. You can see pictures of what these tube worms look like. In the Pacific particularly is where these come from. In the very deep trenches, we find this life, and it's very toxic with lots of gases from the Earth doing its thing, moving and generating this energy. And these plants have learned to adapt and actually live there. So and they're quite primitive, very basic, but they work. They do well down there. When it comes down to mapping the ocean ridges, if we look at the ocean ridges, you can see these are the major tectonic plates. Where the continents and so forth line up. These ridges are in the bottom of the ocean. And what I want you to do with your notes here is go ahead and get a map out. You can print one from whatever you like. Make sure it's a world map. And I want you to draw in these ridges. You may even be able to find an ocean ridge map if you look up on Google. They have everything else. Of course, we have the East Pacific Rise with the mid-ocean. The Pacific one we call the Ring of Fire. It's called the Ring of Fire because at the edges there's so much volcanic activity. And this plate actually kind of rotates around like this. Interesting piece of this plate is in the middle is Hawaii. And Hawaii is what we consider to be a hot spot. And that hot spot is where volcanic activity through thousands and thousands, well, millions of years have pushed through the bottom of the ocean and continue to form that volcanic or those island ridges right there. It curves around like a baseball as it turns. So it's actually a spinning movement like this. These lines are at the very bottom. You see the Atlantic also has one of these big oceans, and then the Indian Ocean as well. So you can see how these ridges and these cracks, essentially, if you think about a hard-boiled egg and you crack it, that's what this would look like. When we look at the ridges on the bottom, you can see how it forces them apart and moves them. We'll talk about this a little more. We know what's down there at the bottom. We can't always get there. It's actually easier probably to go to the moon than it is the bottom of the ocean because of the pressure and the depth there. But we're able to do this because of sonar and echo waves. And because of that, we're able to identify what the bottom of the ocean actually kind of looks like. Now, do we know exactly what's there? No. It's just because it's hard to get down there. But we do know where those mid-ocean ridges are and where they lie and where that abysmal depths are. The first guy that really come up with this, some of you may have written a paper about him, was Harry Hess. Harry Hess was a naval officer. And he suggested that the floors of the ocean move, and they're like conveyor belts down there, floating on top of the mantle. And he was the first to come up with that and suggested that by looking at charts in the Navy and different shipping depths, and he was able to kind of put two and two together like this. At the mid-ocean ridges, what we have is a molten lava that pushes up into that, and it drives the plates apart. So if we think of like two pieces of paper, they sit here, and the lava pushes up in the middle. It separates them apart and drives them, and you can see how that would make these big plates of land move. And that's what happens. Now as that molten comes up, it cools because of the water instantly, and it just gradually drives this and makes it move along. This is what we call the seafloor spreading, of course. This is a good picture. You see the mantle and the lava pushing up in, pushes the oceanic crust, which is, if you remember, very dense, but rather thin, and then it pushes the continental crusts apart and pushing them apart. So if you think about the Atlantic Ocean and the mid-Atlantic ridge there, we actually have the separation and the pushing apart of North America and Europe. And we're moving towards Asia, actually. So this is how this is happening. And we're able to tell that in a number of ways. We can see it through magnetic stripping and drilling samples. Okay, some of the molten material that was down there, we found that they look like strange rocks. They're like pillows. If you take a toothpaste tube and you push it and it squirts out, that's exactly what this rock in the bottom of the ocean looks like in these parts. So that was a big clue as to this happening. The other thing is the magnetic stripping, and this is very interesting. What happens with this is the magnetic strips, as they start to push apart, what occurs here is as the poles of the Earth have flipped through time, and we know that this has occurred, those poles flip because of the magnetic pole. The magnetism switches back and forth, and we're able to actually track that. It's pretty cool. This is one of the major things that we know these ridges are pushing apart. So this is very solid evidence to these theories. The other thing is samples. We go down, we drill, get those samples on the ocean, take a look at them, and they show and they prove that this is actually happening. So we've got a good idea that plate tectonics truly happens, and the engine that drives this, and this is important to know, comes from the bottom of the ocean in these deep ocean trenches being driven by the seafloor spreading. Okay? At the continents, what happens with the oceanic plates, lots of time end up going and driving right up underneath. We end up with a trench right there, and it pushes underneath the continents. This might be California, where you've heard of this, probably the San Andreas Fault. This is an example of what's happening there, but the San Andreas is kind of skipping past, so that's what causes that to occur. But we end up with these subduction zones and that sinking of that deep ocean trench. Okay, so that's where these trenches show up. Those subduction zones, that's where the ocean is sinking back under to be back to the mantle, melting again, and then go back into recirculation. These are the subduction zones. Earth's ocean has been renewed about 200 million years. It takes 200 million years for that bottom floor to be regenerated. So, and we can just track that by the age of the rock and know when it's happening. The Pacific and the Atlantic both have those subduction zones. The Atlantic is actually expanding, and we've got that kind of that rotation in the Pacific happening like we talked about earlier. All right, here's a good picture of those trenches. These are the major ones in the Pacific. You can see how the Ring of Fire comes around, runs right along here, and then through these trenches and up across there in North America and the United States, and that's the San Andreas Fault right there. And then those mid-Atlantic ridges, which we will study closer, right there on the depths. You can see how they push down, and then the West Indies. So you can see where a lot of the earthquake activity occurs. That's where these are really driving it.